All right, let's go through the problems on the homework. So to start with, let's look at number 37. So number 37 asks the probability of your plane being delayed given that your luggage did not connect. So here is my probability statement. Now I did get some other information from the problem before. So to figure this out, it's conditional probability. I'm going to need to make a tree because it's a little more complicated. So to start my tree, I always start with that first letter D, so that's delayed. So the two branches for delayed or on time, 0.85 or 0.15. Next, my next branch is going to be for the no luggage. So coming off of here, if I am delayed, the probability of getting no luggage is 0.35. The probability of getting my luggage is 0.65. Now the way I got this 0.35 here was they gave me that 65% chance, and so I just subtracted it from 100% to figure out this one. All right, now for this branch, the on time branch, which is a 0.15% chance of being on time, I'm going to do my luggage as well off of here. So this is no luggage or luggage. The probability of the luggage being on time, they told me was 95%, so no luggage must be 5%. Now I'm going to figure out all of the branches matching up, going on in a line. So this would be the probability of delayed and no luggage. So I have to multiply those two numbers, and when I do that, I get 0.2975. Notice I wrote my probability statement. I wrote it for each of these after each branch, delayed and luggage. You can see delayed and luggage and here, and then I do all the multiplication. Now I put squares around these because these are the two that I'm really interested in. So now I'm going to go back to my probability statement right here. I wrote it down again, and then I've got expanded form, which is D and no luggage over no luggage. So D and no luggage I can find right up here. Here it is, D and no luggage. So the numerator is not that bad. The denominator is a little more complicated because it's the probability of no luggage. Now no luggage can happen two different ways. It could happen if I'm on time or if I'm not on time. And notice I said that word or. So for these two things, it could be this or that, I add them together, and I show that right here. When I do the math, I get 97.54%. So that's number 37. Now, number 38 over here. For number 38, it's the probability of going to public school given that you actually graduated. So I expanded it right here, and now I'm going to build my tree diagram. Again, I always start with the first letters I see, which is public school. So public school, I'm going to look at the problem. When I read the problem, it told me that there's a 70% of the students go to public school. So that's public school. The opposite branch would be no public school. That's 30%. I just figured that out by doing the complement. 100 minus that. My next branch is going to be the next letter, which is graduating. So I've got this branch going off of here. And the probability of graduating, if you've gone to public school, is 0.75. So not graduating is 0.25. Again, the two options, graduating and not graduating, 0.9 and 0.1. Then I write all my probability statements for following the branches through, public school and graduating, public school and graduating. Then down here, to no public school, graduating right here. So I filled all four of these in, and then I did the math. Now, what I realized is that when I expand my initial probability statement right over here, I actually only need things that have graduation in there. So when I went over here to actually do all the math, do all the multiplying, I realized I don't have to worry about not graduating because I'm not going to actually use that in my equation. So I just multiply the 0.7 times 0.75 to get this, and the 0.3 times 0.9 to get that one. Now I've got to plug in. So the numerator is always the easiest to find first. P, U, and G right up here. Take that 0.52, put that in the numerator. Denominator is always a little more complicated because it's two things. It could be public school and graduating or not public school and graduating. Both of those capture this idea, like that entire circle of graduating. So I have to add those two together. I put it in parentheses to make sure that the calculator knows that my whole denominator is right here. And you end up with 66.04. All right. Now for number 12, we have the probability of favoring the death penalty. So I just went right down looking at that table, and I just added up all the favorabilities, got 62%. This is being a Republican in favoring, so I went to that point on the table that had both of those, which was 26%. Now the next question was, being a Democrat given that you favor the death penalty. So here I need to expand it out, and now I'm just going to go to the table to find these. So D and F, that was just that one place in the table, which is 0.12. The probability of F, now for this, I had to add up all the favorabilities, and I got 0.62, which gave me that 19.35. The last question was being a Republican or favoring the death penalty. So I just used that equation that we have, which would be for the ORs, it's always the probability of R plus the probability of F minus your overlap. And so that's exactly what I did here, getting me 66%. For 23, for 23, what we did was we're looking at pools, having pools and garages. So I first set up my Venn diagram. Now they told me that 17% of them have both, so I always fill in my beginning first. And then I had 21% with, oh dear, I think I put these on the wrong way. 21% with pools. So this, sorry, that should be a P. And so 0.17 plus 0.04 makes 21. And then it was 64% with garages, and those two numbers make that. And that leaves me, when I add all of these up, I only get a 68%, so I need to actually subtract that from 100 to get my 32%, which is the complement of houses that have neither of those things. All right, now I'm ready. So I've got my probability statement, having a pool given that we have a garage. I expand it out to here, and now I just go right to my Venn diagram to fill it in. P and G, the overlap, 0.17. And then PG, that's the entire circle. So I put that right here. And that gives me 80.95%. Now this one, I didn't have to do an entire Venn diagram. It wasn't quite as complicated as those other problems. I mean, the tree diagram, but I could have done it if I wanted to. Okay. For B, they're independent. Now this is a little more complicated. How you know when things are independent would be that if I just multiplied them together, it would equal the same as the probability of both happening, because that is basically the equation when you have independent events. So what I did is I know that the probability of having both, they told us, the problem told us it was 17%, so that was 17%. So now I'm going to check and see, do I get 17% when I actually multiply the probability of having a garage and the probability of having a pool? Well, I multiplied the two and I got 0.1344, which clearly does not equal 0.17, so they are not independent. The other question is if they're mutually exclusive. So mutually exclusive basically means no overlap. I can look right here at this Venn diagram and see that there is an overlap of 17%. So since there is an overlap, they're clearly not mutually exclusive. And that's it for those problems.